is Dr. Wafa Al-Yamani. I am a WiSER pioneer. I'm also an environmental scientist who work with the Environmental Agency Abu Dhabi to protect and sustain our local environment. WiSER stands for Women in Sustainability, Environment and Renewable Energy. It is founded by Masdar. WiSER is an impact-focused platform dedicated to promote gender equality and aspiring women to play a significant and active role in addressing global sustainability challenges. It's also important to know that WiSER aligns with the UAE government vision 2021 of enhancing gender equality in workplace. It also aligned with the United Nations 2030 Sustainable Development Goals. WiSER is proud to have Abu Dhabi Global Market, the award-winning international financial center, as a principal partner. So for today, and on behalf of the WiSER network, I welcome you all to the 5th edition of the WiSER Wisdom Series, discussing an important topic, which is the urban development for the preservation of societies and the environment. So for now, I will hand you over to today's moderator, Mr. Anthony Mallows, the Sustainable Design Advocate and City Planner, who will introduce you to our distinguished speakers and direct the conversation. Thank you for joining us and enjoy the discussion.
Thank you, Dr. Wafa. Very good introduction, much appreciated. Good afternoon, everybody. As Dr. Wafa said, my name is Anthony Mallows, and I'm an architect and a city planner, passionate about sustainable city development. 80% of our energy is absorbed in cities, so this topic today is fundamental to a greener, sustainable future for all of us. I also extend a warm welcome to everybody for joining us. We have such a diverse group from around the world coming together. And please note that today's session will be recorded. Today, we are honored to have two renowned experts in their respective fields to join us for this session. James Baker, who is CEO of the Graphene Institute at the University of Manchester in the UK, and Anne-Marie Joho, who is the Director General and Executive Vice President of CTEC. And before we launch into a discussion with our experts, I would like them each to briefly introduce themselves to you. First, Anne-Marie, would you be so kind as to give us an overview of who you are?
Good afternoon. Thank you very much, Anthony. Good afternoon to everyone. I am Managing Director of CTEC, and CTEC is an engineering consulting company. We operate in 30 countries, and there's about 3,000 of us, just to give you an idea. Who am I? I guess the current motto of CTEC defines me pretty well. I'm both an engineer and a citizen. I learned my engineering 33 years ago in energy production, nuclear energy particularly, but most recently with CTEC, I've been working in another kind of engineering, which is urban, public and private infrastructure development engineering. And for me, what matters is, yes, science and technology, which is my passion, but if it doesn't obviously serve the improvement of our daily life, it's not of no interest to me.
Fantastic, Anne-Marie, thank you so much. And may I then ask James to introduce himself, please?
Good afternoon, everyone. Thank you. I'm delighted to be here this afternoon at this event. So I'm James Baker, the Chief Executive of Graphene at Manchester at the University of Manchester. So graphene, first discovered in Manchester in 2004, two scientists who took some sticky tape and some graphite. And you can all do this at home. If you peel the graphite with a sticky tape, approximately 17 times, you can isolate a single atomic layer of carbon, what we call graphene. But my role in the university is not as an academic. It's really to transition the science from the lab from the universities into products and applications. So my background is from industry, 25 years working in aerospace and defense, predominantly around different technology areas, but also advanced materials has always been a key area, whether it's in aircraft, whether it's in cars, whether it's in new forms of batteries. So very much around how we transition that technology into real products and applications. And that's the role I really do with passion at the University of Manchester. And in particular with today, how new materials might really support the sustainability agenda in the future. Thank you.
James, thank you so much, and Anne-Marie as well. And as our audience will appreciate, the two of you bring a wealth of understanding and experience to this initiative of a sustainable future in cities. So to advance the conversation, I'm going to dive into a series of questions for each of you so you can dialogue with the audience about your respective worldviews on sustainable development. So if you allow me, Anne-Marie, I'll go to you first and ask you, how can the private sector, including engineering consulting companies like the one you manage, help shape sustainable urban development? And how do you marry your efforts with the public sector, including both research institutes like James's and mayors and local authorities? It's a big question, but I'm sure the fusion of those initiatives is important. Anne-Marie, please.
How would I say? Well, I can think of four key contributions of the private sector. I'll start with working with science and technology providers. I think the private sector, including engineering companies, can help orient innovative ideas into sustainable usages. And this is by helping authorities create frameworks to target where the help is needed. So, for example, in CITEC, we have a small company in the CITEC group. We have a small company called Alpin, based in the UAE, which is currently helping the Ministry of Housing of Saudi Arabia create their green building rating system, which is called Musdam. So by doing this, they send the message of where the innovation is needed. Another way engineering companies can help is by incubating innovation themselves. So for example, in CITEC, we have our own internal startup called Adviseo, which has created an application based on Internet of Things and artificial intelligence, which provides a helper to building operators to measure all their parameters and incrementally reduce their energy consumption, up to 30% reduction. Another way that I think the private sector can help is by supporting public authorities, local authorities shape their projects. So this is by combining the involvement of end users and private sector companies like mine know how to run the numbers, to run models. And this helps aligning all stakeholders and prioritizing solutions. So sustainability solutions have their pros and cons, all of them. For example, in CITEC a few years ago, we helped the Bahrain government shape up their urban planning. In order to do that, we engaged the widest range of end users, and we identified the first order levers that were required to take into account for this urban planning. So levers range from, of course, the impacts on the environment. So for example, urban sprawl impacts the rate of artificialization of soils, which in turn impacts, of course, global warming. But also it impacts the waterfront preservation, which is key in Bahrain. It impacts the biodiversity. Other levers include the way people live and make their decisions. For example, if you want people to have all their needs within 10 or 15 minutes, you have to plan the transportation, the urban transportation, so that they will choose the place they live, and therefore they will force urban development in the neighborhoods you want. And with all of that, we created the plan with a number of decisions, including incentives to the private sector, land freezes for bid to go, and investments. Perhaps the last contribution that I think the private sector can make is to assemble innovative technologies with plain common sense, because the projects have to be workable. Just one example, currently we are helping with the King Salman Park rehabilitation project, which in short is creating a big park in the middle of Riyadh in Saudi Arabia to replace an old airport. And in that project, we're having to come up with state-of-the-art technology and solutions to account not only for the functions that are targeted for this park, human services, etc., but also to take into account the timeline we need to develop, to redevelop living ecosystems, and therefore to plan for the services needed for microclimate regulation. And by the way, the current pandemic is pretty relevant in that concept of green spaces in the middle of cities, because just as an anecdote, I found out that the Central Park development in New York City was actually the result of early urban development activities in the 20th century as a result of big pandemics in the United States in late 19th century and beginning of 20th century, which resulted in people thinking, oh, we need to plan for our cities.
Anne-Marie, that's fantastic. What is remarkable about what you're guiding at CITEC is this integration of the private sector initiatives into the public realm. And what I'm going to go to James about is, how does an organization like CITEC merge with advanced research? Because what James is doing with Graphene at the University of Manchester is really cutting edge about optimizing materials. So James, if I might ask, advanced materials can take many years from discovery to being products and applications. We have some very challenging targets towards net zero. How might you or we accelerate these new materials, like what you're doing with graphene, to the market? Please share your thoughts on advanced research into the market.
Certainly. So first of all, just to restate again, I think advanced materials can play a key role in our more sustainable future, from new forms of construction, modular housing, through to lighter weight vehicles or aircraft, through to new forms of energy storage or batteries or supercapacitors. So advanced materials can play a key role in supporting some of those challenging net zero targets that we've set ourselves. However, universities are often great at the discovery. Graphene, first isolated in 2004. Today in Manchester, we now are looking at over 100 other 2D materials. And in the future, we'll end up with stacks of multifunctional material that really will enable our smart cities or multifunctional materials supporting sustainability in the future. The challenge we have, however, is that if you look in history, take, for example, carbon fiber, it took probably 25 years and beyond from discovery of carbon fiber through to the first carbon fiber products in the marketplace. I'm sure many of you now have flown on one of the more modern aircraft that uses a composite wing, but carbon fiber is now 60 years old. So it generally takes a lot of time, a lot of money, a lot of investment, and a lot of risk to take a new material to market. So building on Anne-Marie points, we really need a new model. So as well as the great work across academia around the world, we also need to bridge what's often referred to as the valley of death, the chasm, if you like, that takes a new idea or a new concept from something you can do in a laboratory to something that you can actually build in a factory. So what we've been able to do in Manchester through a unique and special partnership with Masdar is build a facility called the Graphene Engineering Innovation Center, the GEEC. And the purpose of the GEEC is very much around bringing together the best of academia with the supply chain and industry to really accelerate through that valley of death and bring new products into the marketplace. So for me, we need to look at not just the technology, but how we build the supply chain, people who can make graphene. I mentioned earlier, sticky tape and graphite, you can all do at home, but it's not very practical if you want to put graphene in your concrete, if you're doing that at home using a piece of sticky tape. So we need to scale up, and we make graphene not by the gram, but by the kilogram or by the ton or by the 100 ton. And that's the state of where we are today in terms of the graphene supply chain. But we also need to learn how to mix it, to add it, to form these new types of products and applications, and then to rapidly test those into the marketplace. So for me, the model is very much around partnership and collaboration. The partnership we have in Masdar is a great example with that. It builds on the relationship with Khalifa University and the University of Manchester around the science. But if we can get better at bringing together that supply chain, the investment, and reducing the risk through that valley of death, I think advanced materials can play a key role in our sustainable future and meet some of those very challenging targets. In Manchester in the UK, we've set our target to be net zero by 2038. And that means we don't have to wait for another year or another 5 years. We really need to start acting now, because new materials, even if we start acting now, will still take time to certify, to regulate, and we need to do that through partnership and collaboration. But again, I think there's some great examples, and maybe we can talk a few later, where we're actually doing that and starting to really accelerate advanced materials to the marketplace.
James, thanks very much. What's remarkable about what you and Anne-Marie have just said is what's happening in the renewable energy and in the smart materials. There's this integration between advanced research like James is busy with and the application in the marketplace with the private sector that Anne-Marie heads up, because the private consumer is not going to respond to these opportunities unless there's the integration between what James is doing and what Anne-Marie, what you propose, into the marketplace. So Anne-Marie, if I can dive down a little bit into some greater detail and ask you, are smart devices and clean utilities breaking through and making a real difference from your perspective in the private sector? Has the pandemic slowed down matters, or is it an opportunity for awareness about where we should be focusing our efforts?
So I'm an optimistic, but we shouldn't be too optimistic. And I'm not like James. I think there's a lot of effort needed, and we need to focus on those efforts. Yeah, I believe that smart devices, smart services, and clean energy are breaking through. I would say mostly in new projects, new urban development. It's good, but it's not enough. 99% of our current buildings are not new. And that's where we need to have sustainability be implemented. And I feel that there are multiple ways we can make that happen, and we need to keep our minds open. I'll give you 3 examples of very diverse actions which I think are a sample of the kinds of things that we should be open to. The first one is some rather sophisticated service that my company, CITEC, is providing, and it's mobility as a service. So mobility as a service, when you think about it, can range from very elaborate solutions to complex public transportation systems in big metropoles. We do that. When we do that, it's important to think of cradle to grave, seamless transportation, down to the last kilometer. And when you think about it, the last kilometer sometimes is not that sophisticated. It can be just provide a safe parking for bikes so that people don't have to use their car to the train station. But it can also be, in developing countries, making sure that everyone has easy access, sometimes even digitized access, to privately run tuk-tuks. So that's what mobility as a service is. And has the pandemic slowed things down? I would say no. In large metropoles, in fact, initially people feared contamination in public transportation and started using their cars, which led to a lot of congestion. But pretty soon people started thinking, oh, why don't I bike to work? And guess what? It has really triggered very significant technology developments in electric bikes. Huge advancements in electric bikes in the last year. Second example, in water. Very, very key issue in our environmental concerns. A few years ago, we presented the city of Shanghai in China with a combination of solutions to prevent flood, and flood, as we know, leads to pollution of water supply. And among the solutions we proposed was something very simple. It was to identify all the small spaces that were unused in all neighborhoods of Shanghai and de-artificialize those soils and turn them into water drainage soil. And it provided for quite a substantial amount in the solution. And guess what? A secondary effect was to bring vegetation back into the city. And I would say that this calls, or this has something similar with a new preoccupation we've had with the pandemic, if we think about it. I think that the pandemic has led us to go back and look at what is around us in our neighborhoods, rather than immediately thinking, oh, what big commute should I take to a large scale industrial space or shopping mall? My last example will be a totally opposite situation regarding water. Instead of being a flood problem, more a problem of a country which doesn't have enough water, and that's Morocco. In Morocco, we're currently helping develop a green city called Zenata. And in that city, using also state-of-the-art technology to make sure that at the city scale, we're going to use all the rainwater in order to feed the water supply of the city.
Anne-Marie, thank you so much. When I was listening to you and sort of imagining what you were describing, particularly this new city in Morocco that CITEC is involved with, it reminded me of when I was working in Masdar, of how technology is making life more effective and more efficient. But it's the integration between those dynamics which we, both in the professional world and James in the research world, need to connect. So this dialogue that WiSER has promoted about integrating people like you and people like James into dialoguing on how we create and invent solutions is quite remarkable. So now I'm going to move to James and give him a very direct question. James, Anne-Marie has spoken in the broad picture, but I'm going to move to you and ask you, how can graphene and advanced materials support our goal of achieving a more sustainable future? That whole concept of doing more with less. Over to you, James.
Yeah, so thank you. So let me try and give some specific examples that bring this to life, but also just maybe answer some of the chats as well to build on my previous point. So first of all, I mentioned it can take 25 years from discovery through to products. Today, graphene is 17 years young. As I mentioned, there's now a whole family, over 100 other 2D materials. But good examples already we're looking at is, for example, in construction. We recently laid a floor of a gymnasium in the UK, a concrete floor. For anyone who's involved in concrete will know that concrete is one of the major causes of carbon dioxide pollution. So if we can reduce the amount of concrete or look at alternatives, then clearly that will have a benefit in terms of sustainability. Through the addition of graphene, less than 0.1% of graphene into concrete, we've been able to lay a floor of a gymnasium in the UK over 100 cubic meters of concrete. So it's a fairly large floor, using not only 30% less material, it also has no need for any metal reinforcement in the floor. So when you calculate that, both in terms of reduction in material, but also lack of steel, that translates into a significant reduction in carbon dioxide. You then factor into that also that you need less cement mixers, the cure time is quicker, you can actually do subsequent operations much earlier than traditionally. It starts to have a real impact in terms of carbon dioxide reduction. And that's just a start. Going forward, if we can use recycled material rather than new material, and going forward, if we can start to optimize that mix to potentially get 50% reduction, that clearly will have a huge impact in terms of CO2 reduction. Another great area is that of water. Again, graphene has this great property where it can act a bit like a tunable membrane that will allow molecules to pass through a certain size, but will block others. So again, there's some great work we're doing around creating a graphene membrane, where you could take a cup or a beaker of dirty, contaminated, salty water, a small amount of hand pressure, and you could create drinking water. Again, if we could scale that up, that would make water available for, around the world, but also reduce the need for piping water around networks into our houses around the world. So you could take your water from your roof or from the sea to create drinking water would make a huge difference. Again, a great example where that would make impact. And are these visions or dreams? I've mentioned concrete, we're laying the floor of a gym. We'd like to do something similar in Abu Dhabi, and we'll be talking to our colleagues in Masdar if there's a suitable project. We're also looking at different areas in Manchester over the coming months and year. Water, today we can make a small filter, but we're in talks with partners around, for example, making, I'll call it a fridge type device that you may have in your house or your school, where we can take water and we can distribute that within that local village or in that school as an example. Final one is probably that around batteries and supercapacitors. So batteries, as you all know, people are looking at to replace some of our conventional engines. A supercapacitor is where you have a rapid charge and discharge through braking, for example. So maybe our transport in the future will have a small battery, but it'll be complemented by a supercapacitor for acceleration and braking. So we start to move towards this more circular economy, where we're actually regenerating energy from the activity we're doing. So the so-called recycling or circular economy, real examples of the taking today. However, we've got to do that. I mentioned risk, and risk can come in form of investment. It can come in terms of time. It can come in terms of a new material might have health and safety. So we have to be careful. The example in the chat is that Health Canada gave an issue around a graphene face mask. It was actually what I would call a biographene, so it's not strictly graphene, but it was actually a product that was made more for what I call marketing hype than a practical application. So somebody put some graphene on a mask, called it a graphene mask, but it wasn't tested, it wasn't certified as a mask. So that's where the geek comes in. With our partners, we want to do things in a regulated, in a safe way. We want to do it with partners who get standards, who also get the product certified and tested to an accredited level. So if we're going to take these new materials to market, we need to do that in partnership, not just with academia and with industry, but with the various regulatory bodies, the standard bodies, and the other organizations across government. So yes, I think advanced materials can really make a difference. We're seeing some great examples today. Since the concrete lay, the latest in the UK, and I'm sure this is of interest talking to my colleagues in Abu Dhabi, will be laying a section of the A1 motorway in the UK later this year with a graphene road. Why graphene? We want it to be tough. We also want it to stop having any potholes. So anyone who's driven on a bike or in a car over a pothole will know that's not a great thing to do. So if we can get a road without potholes, not only will that road last longer, cause less damage, need less maintenance, it'll be a lot more palatable for everybody to drive on, because you won't be hitting potholes and damaging your tires or falling off your bike. So again, real examples where graphene is starting to make a real difference, but lots we need to do in partnership to make this happen in a safe and effective way going forward.
James, thanks a million. I love your two examples of a carbon less, more effective concrete, because you're absolutely right. We're building cities with materials that are really quite heavy in their carbon footprint. So that's Astley a beautiful example. And the one that's very close to my heart is if graphene can solve potholes, I'm all with you. So now the pandemic has raised the issue of evaluating how we manage cities and how we manage districts and governments manage themselves. And a very interesting analysis that came out that those countries that were run by women were performing far better than a whole lot of other countries managed by other people. So, and this being the WiSER series, Anne-Marie, I have to ask you this question. What role do you see women playing? I don't like the word playing because they're not playing, it's very serious work, but what role do you see women playing in advancing sustainable urban development?
Tough question. I think we need to be cautious at answering this question. Everybody has a role to play, and if we don't all work on it, we will never succeed. By the way, James, the engineering consulting firms will be very interested in your low carbon concrete, and that's cooperation, as you just said. We need to make sure we accelerate the implementation of these technologies. And but okay, let's say, do women have a special role? I think women have an opportunity, and I can think of two special things. The first one would be, I think women can play a special role in enhancing the end user advocacy. Because if you think about it, end users are 50-50 men and women. That's a fact. But in reality, public authorities, local authorities, owners of public infrastructures, even private sector suppliers are a majority of men. And so I would say this reduces the likelihood that of the solutions matching the needs, right? Okay, just plain statistics. And by the way, in our recent work in the Bahrain urban planning, we actually saw this for a fact, that we were lucky to find very strong women networks who helped us make sure that the solutions were really matching the needs. Second role, I think, for women is to be the new messengers. So what do I mean by this? Well, sustainable solutions are often feared by users for their constraints. They are slower, they may not be as comprehensive. And so end user need an empathetic and trustworthy messenger to listen to their concerns and to give them credible answers. So I wouldn't say that men cannot do this, but women are typically viewed as empathetic. This is perhaps just a reputation. And second, I think that women will just be just a new face. And a new face carries potentially, or carries the potential to foster more open-mindedness, just simple that. So I would say women really should step up to the plate in this agenda.
I like that last line very much, because in my experience, when women are sitting at the table in leadership roles, the dynamic is far more perceptive and inclusive than simply a group of my fellow male compatriots focusing in on the logic and the systematization of how to do it. And sometimes the externalities of the benefits are not appreciated. And when they are articulated, all of a sudden, everybody, men and women, come together and say, wow, it's a good initiative, but it has so much greater impact. So thank you so much for taking that answer. And now I would like to bring the audience into what Anne-Marie and James and myself are doing today. And we have a poll question that we'd like to pose to all of you. And I'm going to read it out aloud, but it's also on your screen. And the question is, do you think developers of cities in the future should get economic benefits if they invest in longer term sustainable development. And I'm going to give you a little while to respond to this because it's important to get your feedback from the audience, and then we can take the discussion further. I'll give you a minute or so to answer this, and then I will rely on our great WiSER seminar organizers to tell me how we go on to responding to this, because I think it's key. Yes, it will encourage. No, it won't. And if you're not sure, don't be shy to be not sure, because that tells us that we have more work to do about socializing the content of sustainable development. Ha! Look at that. Absolutely marvelous. Overwhelming response that yes, it's definitely a key to the future, that it will encourage more developers. And what I like about the audience, obviously very informed and very perceptive, is that the economics of sustainable development is all about not only amortizing the capital cost, but also capturing the benefits of the operating costs and the long life cycle of what we do. So Anne-Marie, firms like CITEC, your firm, and James, what you are doing is integrating the application and the research into creating cities that are far more durable, but also far more effective in yielding results, not only over 5 or 6 years, but over 15 or 25 years. So thank you very much on that. Now, Anne-Marie and James, you've seen the results of the poll question. So Anne-Marie, if you could please share your advice and thoughts on this question, and also bear in mind the response. We've got quite an aware audience we're dealing with today. And then James, I'm going to ask you after Anne-Marie if you could share your thoughts on the poll's result, but also the question. Anne-Marie, go ahead, please.
Well, I'm going to challenge the audience a little bit, because I would actually like to have both. You know, I like the second sentence, which says, you know, it should be technology driven. And I heard James, and I agree with James on the risk factor. We should encourage people to take risk. So, and it's not that easy to guarantee return on investment. So I think there's a little bit of both. And I feel that the funding and the subsidies and the encouragement, the incentives have to be well thought through initially, including by those planning the urban developments, public authorities, etc. I'm a strong believer in public support to technology development, but we need to remember that this public support needs to go beyond the technology development, beyond funding universities and research centers, because oftentimes the first implementation is where things become very difficult. And that's where probably the highest risk lies. Perhaps one last word beyond asking, you know, public authorities to fund first implementations. One last thought would be, when somebody decides to fund or incentivize something, a key to the overall success, ultimate profitability of the solution, so that it becomes a solution on its own and the private sector takes care of it, a key is really to set the proper indicators to make sure that we measure at the end, is it a success or is it not a success?
Yeah, that's very good. That's very interesting. James, why don't you weigh in here on the same as Anne-Marie?
And again, I think I agree with Anne-Marie. I'm not surprised by the answer, but using my concrete example, you know, a year ago, it was very difficult to get people interested in a graphene concrete. Sustainability net zero targets came along, And it started to get people thinking more seriously. But I think probably initially people thought, oh gosh, adding graphene, that's going to increase my costs. There's going to be no business case, there's no model, it's going to have to be subsidized. There isn't a business or a commercial case to do that. As I pointed out, we're now finding 25% less material, no metal reinforcement, quicker cure times. Suddenly, now when you look at the business model, it's not only lower CO2 footprint, it's potentially more competitive than a conventional concrete. So I actually think the answer is a little bit of both, that yes, sometimes policy or government can set targets, can initiate change. You know, another good example, 3-4 years ago, people probably would have laughed if we talked about all electric cars. But now in many countries, we're phasing out petrol and diesel cars. And that's really led to an increase in developments of batteries and other fuel cells, hydrogen type technologies. Hydrogen's another great example for aircraft. You know, 2035 to have a net zero aircraft flying across the Atlantic. That won't be done using conventional engines. It's going to be electric or hydrogen or a hybrid. So sometimes policy can force change, but to make it commercially viable, you have to do that in a way that makes commercial sense. So I think there's some lessons there that if we do things well, going back to collaboration, I think there's a sweet spot. The second question is a little bit of technology push. Graphene 5-10 years ago was guilty of a little bit of technology push. I've got this wonder material, how do I use it? But through the partnership with Masdar and the creation of the Geek, we have this ability to mix that academia with industry, not to talk about technology, but to talk about problems, to talk about sustainability, lightweighting, performance. And if we can get that sweet spot of academia working closely with supply chain industry, I think we can find a business model that takes these new materials to market in a much smarter way than we traditionally have. So I think the future is exciting. I think we have got a very well-informed audience, but yeah, I think there's a way of doing both government-led, but also commercially viable propositions as a positive way forward.
Thank you, James. I think one of the remarkable things all of us on this webinar have experienced is the role technology and advancements in technology have played on making our lives more effective, more efficient, and more pleasurable. I remember when I was growing up, the first telephone we had took 4 years to be installed in Johannesburg, and it was a party line, and there was one phone sitting in the front hall of the house. And just look at that evolution within less than one lifetime to going to smartphones and what we're doing today on this webinar. Quite remarkable. So it's good to see that there's so many questions from the audience, and I want to bring them in a bit, and I'll try to get as many as possible and ask you to come on camera and to ask your question to the panelists. However, in looking around, I would like to first ask Banish Siddiq, can you come on camera? And please, Siddiq, Banish, please ask your question. I think you need to unmute yourself, Banish.
Thanks.
There you go.
Yeah, thanks. Hi, my name is Dr. Banish Siddiq, and I did my PhD from the University of Manchester, and currently I'm CEO and founder of a startup company that is based in Graphene Engineering Innovation Center. My question is to James Baker. So there is no doubt graphene is a wonder material with new application ranging from aerospace to indoor farming recently being developed. But what does the supply chain for graphene look like, and how robust it will be as demand further increases? Thanks.
Thank you.
That's
Banish.
a great question, Dr. Banish. I'm going to give James 10 seconds to mull it through before he replies. And I must congratulate you on what you have started coming out of a research center, Banish. Very well done. James, over to you.
So I touched on earlier, but the supply chain is still developing. Today, we have companies who can make graphene by the gram, by the kilogram, by the ton. But I think we need new forms of graphene in the future, maybe from a bioprocess. So for example, do we take a biochar from tree waste and recycle that? there's some really interesting work coming out of Rice University in the US about something called flash graphene. And that's where you take plastics, recycled plastic, you then put them through a effectively process to create a graphitic material. Going back to concrete, imagine if we have one end of recycling your aggregate, the other end of plastic waste going into a machine, coming out with graphene and concrete, mixing that together, and then locally you're producing your graphene concrete at your point of supply. So yes, you can buy graphene material today, Beanish, and there are a number of suppliers around the world. But I think there's a huge development going forward from biomaterials. The one that probably excites me most is, can we take graphene from CO2 or methane? So take the carbon from a material like that, that traditionally is a waste, and create that into a value material that we can add to soil, or we can add to composites, or we can add to membranes. That will really make that circular economy come to life.
James, thank you very much. And Benish, thank you so much for your question. And we wish you every success as you advance this connection between advanced materials and advanced businesses. Fantastic. So looking at the questions from the audience again, I think I'd like to hear from Iman Al-Suwaidi. Iman, could you please come on camera and ask your question, please?
First of all, I would like to thank the panelists for such an insightful and rich information that we have been provided today. And my question is directed to Ms. Anna Marie, and it's about, is the most efficient way to create sustainable cities to retrofit and remodel our existing urban cities, or create entirely new ones? And after the second part, if you may allow me to do that, is, are there any examples for either in action?
Wow, that's a good question, Iman. And it's something that I was dealing with and we debated at length when people will ask us, why is the UAE building Masdar City a sustainable city from scratch and from new, versus there are so many cities that can be repurposed and readjusted. So I've given Anne-Marie about 10 seconds to mull that through so she can respond to your question, Iman. Anne-Marie, over to you.
Yeah, indeed, it's a key question, probably one of the half-dozen key questions we need to focus on if we are going to save the planet, to make it short. Honestly, I think we need to do both, because either one has its advantage and will help the overall purpose. Of course, like I said, in old countries like France, for example, 99% of the buildings in which people live are more than 2 years old and are not about to be demolished. So we are going to use them for the next decades. So we need to focus on them. We need to refurbish the existing urban cities, because if we focus only on building new ones in a sustainable way, it will not be quantitative enough. And I'm an engineer, you know, so I add up things and I determine that it's not going to fly. So you have to look at existing facilities. It's not easy. And by the way, looking at that often means to rethink the way we continue to develop existing developments. Instead of extending them, urban sprawl, reuse locations within the old cities that for some reason are not totally used or have stopped their usage. Sometimes bring vegetation back, so de-artificialize soils, and sometimes simply pile up. And that's why I would say sustainable cities probably have to go a little higher up in order to use less soil. But we also need new cities like Masdar, of course, because they set the stage. They are an example, and they set also quantitative targets. Of course, old cities will never become as sustainable as new cities which were designed for that. But at least they give us a purpose, you know, they give us a target, a quantitative reference that we can use.
Thanks, Anne-Marie. I like very much the idea of using a new sustainable city as the pilot project, where the new sustainable city is measured and judged on its performance, so that you can then replicate back into existing cities how to intervene. And particularly your idea of repurposing space in existing cities in modern, innovative ways that might take less space, but also be a function of re-greening those cities and restoring the soil to where it goes. I think I would like to ask, we have a few minutes left. I think I'd like to ask James and Anne-Marie if they have any final thoughts or comments about how WiSER and how advanced research and how professional engineering organizations like yours, Anne-Marie, are looking forward. Just 30 seconds each. Where do you think the effort needs to be made, and where are you wanting to take research and professional practice? So, and let me go with James, because then we can end with you, Anne-Marie. James, you're going to have to unmute yourself.
So very briefly, advanced materials agenda is going towards these heterostructures, so this multifunctional material that really opens possibilities. I think building on today, I'm a passionate engineer. I think really we need to encourage the current graduates, future businesses into this new world of advanced materials. So Dr. Siddiqui, as an example, CEO of a business looking at new food production going forward, using a hydrogel that means you can do intensive internal farming. So this new ecosystem of startups, spin-outs, but not just a startup, scale-ups. How do we go from smart people from universities, from schools with ideas? We help them take those ideas forward and bring them into our new businesses of the future. That's where I think we'll see some real acceleration and growth in support of sustainability. And that's why I'm here today and supporting WiSER, because I think we need to not just get the male population, we need to really excite and accelerate these great female engineers for the future.
Lovely. Thank you very much, James. Anne-Marie, your closing comment.
Yeah, thank you very much, James. As a matter of fact, when you asked me, what is the role that women can play, what I really wanted to say is, other than being very brilliant technology developers and smart engineers, so certainly, but going beyond male, female, I think one of the things we need to open up to is to be more comprehensive in the integration of everyone, because this is how you reach sustainability, after all, is when you take into account the whole ecosystem. So those who were not involved in decision-making, in urban development, in science and technology development, just because they were not the specialists of that domain, have to be more involved. So I talked about end users, but I'd like to just give one more example that we went through in CITEC. A few years ago, we were celebrating our anniversary, and we asked everyone to dream of what would be the newspaper headlines in 5 years celebrating an achievement by CITEC. And nearly all of the proposals we got, mostly from our youngest engineers, were about saving the planet. And this gave us really the direction to follow, because our youngest colleagues are representatives of what young students, young people really are looking forward to. And we should just listen to them, because they have very smart ideas, which we can combine with our good old science and come up with the solutions for tomorrow and for sustainability.
Wow. Anne-Marie, thank you. James, thank you. And on that note, I'd like to conclude this 5th edition of WiSER Wisdom series. I hope that you found it all engaging and enlightening, and remind you that you can revisit what we talked about today, because the whole session has been recorded and will be available to review. I would also like to give a very, very special vote of thanks to James and Anne-Marie, our esteemed guests, for giving us your time and sharing your knowledge. And thank you particularly to everybody who joined and contributed to today's conversation. Goodbye. James and Anne-Marie, please wish everybody well, and we look forward to seeing you all again on our next session. Stay safe, everybody. Bye-bye. Thank you so much.